Unlock the secret language that powers all of computing. Ever wondered what language computers use to communicate? It's not English, Spanish, or any other language we humans speak. It's a language of logic and precision, a language that helps computers make decisions and process information. This language is a form of discrete mathematics. So, what exactly is discrete math? Unlike the continuous mathematics that you might be more familiar with, where numbers flow smoothly from one to another like a river, discrete math deals with distinct, separate values. Think of it as a string of pearls, where each pearl is distinct and separate from the others. And why does it matter in computer science? Here's the thing, computers think in binary, in ones and zeros. They operate on distinct units of information. And because of this, the principles of discrete math are woven into the very fabric of computing. It's the key that unlocks the power of computer processing. Let's take a simple example. When you're using a search engine to find information, the computer doesn't just randomly select websites. It uses algorithms, a fundamental concept in discrete math, to process your search terms and return the most relevant results. It's making decisions, processing information, all based on the principles of discrete math. Or consider a video game. The computer uses discrete math to calculate the trajectory of a thrown object, the collision of characters, or the strategy of an AI opponent. All these complex operations are handled using the principles of discrete math. So when you're using your computer, you're not just typing away on a keyboard. You're interacting with a sophisticated system that uses discrete math to process information and make decisions. It's like you're speaking the language of computers, the language of logic and precision. And the more you understand this language, the more you can unlock the power of computing. So when you're using your computer, you're actually using discrete math. Prepare to delve deeper into this fascinating world as we decode the language of computers. Let's embark on this journey together. Stay tuned. Logic is the backbone of computation, and it all starts with a simple yes or no. Imagine a world where every decision, every action, is boiled down to two choices: true or false, yes or no, 0 or 1. That's the world computers live in, and it's all thanks to a concept called Boolean logic. Named after George Boole, a mathematician from the 19th century, Boolean logic is the binary system that forms the basis of computer programming. Now, you might be wondering how something as complex as a computer program could possibly be built from such simple binary choices. Well, that's the beauty of it. Boolean logic allows us to build complex computations from simple binary decisions. It's like building a skyscraper from individual bricks. Here's how it works. In Boolean logic, every statement is either true or false. There's no in-between. This might seem restrictive, but it actually gives us a lot of power. You see, by combining these true or false statements in different ways, using logical operators like and, or, and not, we can express pretty much any logical condition we can think of. For example, let's say we have two statements. It's raining and I have an umbrella. We can combine these statements in different ways to express different conditions. If both statements are true, we could say it's raining and I have an umbrella. If only one statement needs to be true, we could say it's raining or I have an umbrella. And if we want to negate a statement, we can use not, as in it's not raining. This might seem simple, but remember, every piece of software you use, every video game you play, every website you visit, they're all built on millions and millions of these binary decisions, these bits of Boolean logic. So every time you use a computer, you're actually navigating a maze of millions of these binary decisions. That's the power of logic in computation. And that's why understanding Boolean logic is so crucial to understanding the language of computers. So next time you're typing away at your keyboard, remember, you're not just pressing keys, you're speaking the language of logic. Unlock the secret language that powers all of computing. In the world of computers, everything is part of a set. Just like a shopping list is a set of items you need to buy, or a playlist is a set of songs you want to listen to, In computer science, a set is a collection of distinct objects, considered as an object in its own right. Let's delve a bit deeper into this. Sets are fundamental to computer science. They help us categorize and manage data efficiently. For example, think about an online library. The books can be organized into sets based on different categories, like fiction, nonfiction, mystery, and so forth. This organization allows us to locate a book easily, doesn't it? That's the power of sets. Now, within these sets, we can have relations. Relations in discrete math are like relationships in real life. They show how elements in one set are connected to elements in another set. In our library example, we can have a relation between the set of books and the set of authors, showing which author wrote which book. But it doesn't stop there. Relations can be reflexive, symmetric, transitive, and so on. These properties help us understand the depth of the connections between the sets and provide a structure to the otherwise chaotic data. Moreover, sets and relations are not static. They are dynamic and constantly changing. As new books are added to the library, the sets and the relations between them evolve. This flexibility makes sets and relations a powerful tool in computer science. So the next time you're sorting your music playlist or categorizing your photos, remember, you're using sets and relations. They are behind the scenes, making your digital life easier and more organized. And remember, math is not just numbers. It's a secret language, a set of rules that powers the digital world. Stay curious, stay connected, and keep exploring this fascinating world of discrete math. Don't forget to subscribe for more insights into the language of computers. Unlock the secret language that powers all of computing. Ever wondered how Google Maps finds the fastest route to your destination? Well, it's all down to the magic of functions and algorithms, key concepts in the world of discrete mathematics. Functions, in the simplest terms, are the relationships between inputs and outputs. Imagine you're a chef. Your ingredients are your inputs, and your delicious dish is the output. The function? Well, that's your recipe, the process that transforms the inputs into the output. Now let's delve into algorithms. Essentially, an algorithm is a series of steps to solve a problem or complete a task. Think of it like a set of directions. You start at point A, follow the steps one by one, and voila, you've arrived at point B. In the realm of computer science, algorithms are the bread and butter. They're the detailed instructions that tell a computer what to do. Whether it's sorting a list of numbers from smallest to largest, or finding the fastest route from home to your favorite pizza place, it's algorithms that make these tasks possible. But how does this all tie in with discrete math? Well, discrete math is the study of mathematical structures that are fundamentally discrete, not supporting or requiring the notion of continuity. Functions and algorithms, with their step-by-step processes, fit perfectly into this realm. They're the building blocks that allow us to construct more complex structures and solve more complex problems. So next time you use Google Maps, remember the complex functions and algorithms working behind the scenes. They're analyzing traffic patterns, calculating distances, and generating multiple routes, all in a matter of seconds. So whether it's sorting a list or finding the fastest route, algorithms make it all possible. It's time to appreciate the beauty and complexity of these mathematical concepts that power our digital world. Stay curious, keep exploring, and remember, math is not just about numbers. It's about patterns, relationships, and problem solving. And that, folks, is truly beautiful. So, what have we learned about the secret language of computers? Well, we've embarked on a fascinating journey through the world of discrete mathematics, uncovering the key concepts that underpin the realm of computer science. We've discovered that this secret language is more than just numbers and symbols. It's the logic and structure that powers our digital world. We began with the essential language of logic, Boolean logic to be precise. This is the binary language of true and false, yes and no, 1 and 0. It's the foundation of all computation, the basic building block of all decision-making in computers. From there, we delved into the world of sets and relations. We learned how these simple yet powerful concepts help us to categorize and relate data in meaningful ways. We saw that, in the universe of computing, everything can be thought as a set of elements, and the relations between these sets are what give them context and meaning. Next, we explored the intriguing world of functions. These are the rules that transform input into output, the algorithms that guide the flow of data. Functions are the heart of any program, dictating the sequence of operations that lead to a desired outcome. Lastly, we touched upon algorithms. These are the step-by-step procedures that solve problems and accomplish tasks. From sorting data to searching databases, algorithms are the workhorses of computing, tirelessly executing their tasks with precision and efficiency. Throughout this journey, we've seen how these seemingly abstract concepts of discrete math translate into tangible, practical tools in the field of computer science. We've discovered that this secret language is not so secret after all, but rather a shared language that bridges the gap between human thought and digital computation. Remember, math isn't just numbers. It's the language that powers our digital world. So keep exploring, keep questioning, and keep learning. The world of computer science is vast and exciting, and there's always something new to discover. Don't forget to subscribe for more insights into the fascinating world of computer science.